In previous lecture, we have seen MODI method, that is modified distribution method, and in that we have seen that how to reduce our time for identifying the additional transportation cost. For that, we have used UIs and VJs as additional variables, and from that we have identified the additional transportation cost as Cij minus UI plus Vj. Here in today's lecture, we will continue from the last problem and we'll see that how to reach to the optimal solution, alternate solution, and how to identify that. Okay, so here I am showing you previous problem. So previously, we were having this problem. We have solved it. You observe that uh, here we have previously first solved by stepping stone method, then introduced the Modi method, and then we have reached the final solution, this one. Here, if you observe, then this value is 0. So, and all the others are greater than or equal to 0. So this says that you are having an alternate solution to the game solution. First of all, we will identify the these solutions transportation cost. So that transportation cost is here 3 times 400, that is 1200, plus this is 600, plus this is 500 and 1000, plus this is 1050, plus this it is 200, plus this 1800. So that sum is here, this two sum is 1800, plus this two sum is 2050, and this two sum is 200, sorry, 2300. So total is 4 plus 1, 5, 8, 5, 0. Okay. Now, to find the alternate solution to the given situation, first of all, let me write the whole table. Here the transportation cost were 3, 9, 8, 6, 4, 3, 2, 1, 9, 4, 3, 6. Okay. And here you are having transportation cost. So for that, first of all, find out the loop, whatever is possible. So from here, we can go to here, then here, here, and come back. So this is our loop. Here, what are the negative corners? This and this is your negative corner. What are the positive corners? So this and this is positive corner. From the negative corner, you have to select the minimum. So minimum of 200 and 350 is 200. So we will add 250, 200 here and here and subtracted 200 in these two corners. So here this 400 is as it is, so I am writing as it is. Here 300 is also as it is, so I am writing as it is. Here this 200 is also as it is, so I am writing it as it is. Here this 200 is removed and it will be added here. So 200 Here it is 350. So 350 minus 200, that is 150. Here it is 250 plus 200, that is 450. Okay. There is no need to find out the additional transportation cost because anyhow this is your optimal solution. But let's say the cost is same as the previous one. So for that, let me copy this table and move it to down so I can calculate the transportation cost. So for this, the transportation cost is 400 times 3 plus from this it is 300 times 6 plus from this it is 200 times 2 plus from this it is 200 times 1 from this it is 450 times 4 and from this it is 150 times 3. So the sum uh, here it is 1200, here it is 1800, then here it is 400, here it is 200, here it is 450 times 2 it is 900 and then 2 it's 1800 and here it is 450. Okay, now the sum of these values is this is 3000, this is 600 and this is 2250. 3 plus 2 it is 5, 6 plus 2 it is 850. So here also you are getting the same transportation cost, but this is your another solution than the previous one. You know that. Okay. So this is a way to find out the alternate solution. Today we will start one more problem and we'll solve it via any proper um, method. Okay. Better we go with Vogel's approximation method and then we'll go to the modified distribution method if it is required. Okay. Let now we are having source is S1, S2, S3 and S4. Destinations are D1, D2, D3 and D4. The transportation costs are given in this way that 5, 4, 3, 4, 2, 6, 9, 3, 4, 8, 6, 3, 2, 4, 6, 9. The supply from S1, S2, S3, S4 are here, that is 200, 300, 200 and 400. So here total supply is 500 plus 600. So it is 1110. Okay. Now the destinations requirements are 150, 250, 350 and 100 minus this to get the balance one. So what is the sum first of all? This is sum is 3 plus 1, so 400 and 400 plus 350. So it is 467750. So 250 plus 100, so 350. Okay. So This is our balance problem. I am taking random problem, okay? Uh, Now we apply, first of all, the Vogel's approximation method to reach to the initial basic visible solution via shortest way, okay, to reach to the optimal solution. So all we will do is find out the minimum and next minimum. So here 3 and 4, so their difference is 1. Here minimum is 2 and next minimum is 3, so their difference is 1. Here minimum is 3 and next minimum is 4, so their difference is 1. Here minimum is 2 and next minimum is 4, so difference is 2. Here minimum is 2 and next minimum again 2, so difference is 0. Here minimum is 4, different and next minimum is again 4, so difference is 0. Minimum is 6, minimum is 3, next minimum is 6, so difference is 3. Minimum is 3 and next minimum is also 3, so difference is 3. 0. So our maximum number is this. So corresponding columns minimum, that is 3, there we will allocate whatever is maximum possible, that is difference of minimum of 200 and 350, that is 200. So we will allocate 200 here. Here we are left with now 0. Here we are left with 150. Since this is 0, this row is cancelled now. So we will not calculate anything now onwards for this one. Okay, now here minimum and next minimums are same. So here I am writing 1, 1, 2 as it is. Here it may change. So here minimum is 2 and next minimum is 2. So difference is 0. Minimum is 4 and next minimum is 6 because this row is cancelled now. So 4 and 6. So minimum difference is 2. Minimum is 6 and next minimum is also 6. So difference is 0. Minimum is 3 and next minimum is also 3. So difference is 0. So maximum is 2. From there, choose a minimum. So here it is minimum is 2 and here minimum is 4. So we will go for this minimum. So here it is 2. Whatever maximum allocation possible is there, that is 150, we will allocate there. This is 0 and this is now left with 250. So this column is cancelled. So now we will not calculate anything for this. And since column is cancelled, these differences will be same. Here for rows, now we have to again calculate. So minimum is now 3 and 6. So difference is 3. Minimum is 3 and next minimum is 6. So their difference is again 3. Minimum is 4 and next minimum is 6. So difference is 2. So maximum values are 3 and 3. So for that, choose a minimum value, that is 3 and 3. Again, we are having a tie. So we can choose for which maximum transportation is possible. So here it is 300 and here it is 200. So maximum is for this. So we will allocate 300 unit. Here we are left with 0 and here we are left with 50 units. Okay, so since this is 0, this row is now cancelled. So now we are having this, so this difference will be same as it is, but here difference will be changed. So 4 and 8 are left, so their difference is 4. 6 and 6, their difference is 0, and 3 and 9, so their difference is 6. For maximum is 6, so we will select minimum here, so that is 3 and 9's minimum is 3, and we will allocate whatever maximum is possible, that is 50. So here allocation is 50, here we are left with 150, and here we are left with 0. Okay, now take, since this is 0, this column will no more be calculated, this difference will be as it is, so 4 and 0, here 6 and 8, so the difference is 2, 4 and 6, again difference is 2. So maximum is 4, we will allocate whatever minimum, that is 4, whatever is maximum possible, that is 250 and 250. So we are having 250 here, here we are 0, here we are having 0. Okay. Since this is and this is both are 0, so this row and this column both are cancelled. Here we are having only 150 left, so here we will allocate that. Okay. So this is our initial basic visible solution. Okay. Now let me copy this table. I want to show you one thing. Here we are having how much sources? 1, 2, sorry, now 4 destinations and 4 sources. Okay, so your M is 4, your N is also 4. So M plus N minus 1, that is 4 plus 4 minus 1 is 7. And the allocations are here 1, 2, 3, 4, 5, and 6. So here allocations are 6, that is strictly less than this. So if you will try to find out UI and VJ in modified distribution method, you will not able to find out all of them by assuming only one. Let me show you. Here I am taking U1, U2, U3, U4, V1, V2, V3, V4. You can take anyone to be 0. I am taking V3 be 0. Okay. So here it is 3. So this is 3. Since this is 0. Okay. And since this is 6, we have to take this must be 6. If you are taking this 6, then here we are having 3. So to make that sum 3, here we are required to take minus 3. Since this is minus 3, this is 3, so you have to take V to be 6. Now, if you want to find out from this U1, U2 and V4's value, you are not able to find out that. Okay. Why it is happening? That is because when we have tried to allocate this 250, both two at two places we get simultaneously 0 at here as well as at here. Both get 0 at the time, and still we were left with to allocate this 150. Okay, that is the reason why we are in this situation. This situation is called degeneracy in the transportation problem. And how to solve that degeneracy? So it's very simple. See, if you will allocate something here, then is it possible to find out a loop from all allocated cells to this point? So let's check. From here, if I will go to here, then only possibility is to come here, and then there is no way to reach that point. Okay, so uh, this is not a good choice to find the path. Okay, if not then go to here, then you can come here, come here, and come back. But here there is no way to reach to this point, come back. So this is one of the choice where you can allocate something. What something that I am going to explain. That is a one choice. Let's think about this point. Can I do that from here to here, then here, then here, and I am not able to come back to this point. So that is also one of the choice. If I think about this point, then from here, then there is no path. So that is also one of the choice. If I think of this point, then from here, and there is no way to come back. For this point, from here to here, and there is no way to come back. From here also there is no way to come back. But if I think of this point, then I from here to here, and come back. So that is possible. So we will not go for this point. Similarly, if I think of this point, and from here I can go here, and come back. So this is also not a good choice. Here, from here, I can go to here, then come back. So this is also one of the choice because there is no way to reach to this point back. Similarly, for this, there is no way to reach. Okay. So these two are not a good choice. All the others are possible. Because for that you cannot come back to the same point via that loop. Okay, so you can choose any. I am choosing this one. You can take, uh, from that you better select the minimum. Okay, so I am taking this two. For that, take epsilon. Epsilon is too much small number. And obviously greater than 0. But actually we are not transporting anything from V2 to from here source 2 to destination 1. Okay, but we are taking this epsilon just to remove this degeneracy. So how much numbers you will take epsilon, that will depend on this uh, difference of this, that is m plus n minus 1 minus actually allocated cells. If you are having actually allocated cells 3, then you have to take 4 variables which are degenerate. Means 4 place, at 4 place you have to take epsilon. Okay. So here I am taking here. You can take epsilon anywhere, but the smallest number from where it is possible, that allocating there will be give you the optimal solution. This solution is optimal or not immediately. Let's take start from that. So here if this is epsilon, then since here V2's value is 6, here it is 2, so your this value must be minus 4. Since this is minus 4, this is 2, then you have to take this 6. If this is 6, here to make 4, here you have to take minus 2. Okay, now find out the additional transportation cost. That is 5 minus 3 minus 4, that is minus 1, 5 minus minus 1, that is 6. So additional transportation cost is 6. Here 4 minus 3 minus 2, 3 minus 2 is 1, so 4 minus 1 is 3. Here 6 minus 6 minus 2, so 6 minus 2 is 4, 6 minus 4 is 2. 6 minus 6 minus 4, 6 minus 4 is 2, so 4 minus 2 it is 2. 8. 8 minus 6 minus 2. So 6 minus 2 is 4. So 8 minus 4. So it is 8. Here it is 6. So 6 minus 0. So 6 minus 0 is 6. So 6 minus 6 is 0. 9. So 9 minus 6 minus 3. So it is 6 minus 3. So 3. So 9 minus 3. So it is 6. Here it is 4. So 4 minus 3 minus 3, it is 0. So here 4. 9. So 9 minus 0, 6 minus 0. So 6 minus 0 is 6. So 9 minus 6 is 3. So everywhere your additional transportation cost are greater than or equal to 0. So this is your optimal solution. Okay. But again here we got 0. You know how to find out the transportation cost. But here this value is 0. So you know that it is having alternate solution. So to get the alternate solution, you have to form a loop. So what is a possible loop for this? So if you start from here, you are having a way to come here, and then there is no possible loop from here to come here, then come here, here, and then come back. So from here, I am coming to here, then here, here, and come back. Okay. So if you think about the negative corners, then this is positive corner, this is negative corner, this will be positive corner, this will be negative corner, this will be positive, and this will be negative corner. Okay. So from the negative, let me highlight so we can clearly see. This is your positive corner, this is your negative corner, this is your positive, this is your negative, this is positive, and this is negative corner. So from negative corners, we will select the minimum, that is 300, 150, and 150 is minimum. that is 150. So we will transport 150 units from here. So our next table will be 5, 4, 3, 4, 2, 6, 9, 3, 4, 8, 6, 3, 2, 4, 6, 9. First of all, I write those previous allocated cells which are not going to be affected, that is 200 and here 250. Those two things are not going to be affected. At the negative corners, here there is 150, so minimum is 150. So I am transporting that 150 other ways. So here it will be added 150. Since I have added here, it will be 0 here, so I am not writing anything. Here it is 150. Then here it is 150 subtracted, so 150. Here 150 added, so it is 200. Here 150 is subtracted, so I am not writing anything there. Okay. Now again, we are in the same situation. 1, 2, 3, 1, 2, 3. So total 6 allocated cells. If you will think about the UI and VJ, you will not able to find out the actual uh, UI and VJ's value by assuming only one's value. So let me take here U1, U2, U3, U4, V1, V2, V3, and V4. You can take anyone to be 0. So again, taking V4 is equals to 0. From that, your V2 is equals to 4. In U3 is equals to 6 because 6 plus 0 must be 6. And that's all. We are not able to find out anywhere else what is possible. So if you have observed in the previous case, see here, okay, sorry, here. While we were finding out the possibilities to find where it is allocation is how to find out UIs and VJ. So only was previously this and this was known, and here it was this, and this was known. So their intersection box was not valid to find out. They take the epsilon things. Okay. Similarly here, this is known and this is known, and only this is known. So this is these two are only possibly area where you cannot take the epsilon thing. So anywhere else you can think about epsilon. Minimum is 2. So let's think about can I take epsilon here? So if yes, see how. From here, if I go to this, then I will come back to here, then I will go here, and there is no loop to come back the same point. So, and as I have already said that you go to the minimum selected. So I am taking epsilon here. And then UI and VJs. Okay, so this is your alternate solution. Okay, now we already have reached into the final optimal solution. I am explaining you that how this is actually alternate solution. So if this is epsilon, here you have to have take 2. If this is 2, to make this 2, here you have to take 0. Since this is 0, now to make this 3, you have to take this and 3. And since this is 6, here this is 3, so you have to take this is minus 3. Oh, sorry, this was also previously known, okay? Yes. Now, find out the additional transportation cost. Here, that is 5 minus 3 plus 2, so minus 1, 5 minus minus 1, it is 6, 4. 4 minus 3 plus 4, that is 1. So 4 minus 1, that is 3. Here 4. 4 minus 3 plus 3, it is 0. So 4. 6 minus 0 plus 4, that is 4. So 6 minus 4, it is 2. 9 minus 0 plus 6, it is 6. So 3. 4 minus, oh sorry, I have forgotten to find out V3. Here it is 3, here it is 3. So you have to take this means 0. Here it is 4 minus 0 plus 2. So it is 4 minus 2. So 2. 8 minus 4 minus 4 plus 0. That is 0 plus 4. So 8 minus 4, it is 4. 6 minus 6 minus 0. So it is 0. 9 minus 3 minus 0. So 3 minus 0 is 3 plus 0 is 3. 9 minus 3, it is 6. So this is your alternate solution, and this is also optimal solution. Okay, we have checked. At home, you try similar such problems and uh, say that you are able to check the alternate optimal solution, optimality test, Vogel's approximation method, modified distribution method, stepping stone method at your home or not. If you have any doubt, ask in a Telegram group and we will discuss. Thank you.